Hello, and welcome to the first episode of 6 of Elevating Electronics. Today, in this video series, we will be talking about the Otis Touch Tube, and in this first episode, we will take a look at them, their history, and what exactly makes them tick. So first, a little history lesson on these tubes. Don't click away yet, I promise I'll make it short. So, back in the 40s, when they were first starting to use vacuum tubes, and I won't get into detail about specific vacuum tubes, specific types and all that, but all I'll say is that it was discovered by an inventor, specifically W.H. Bruns, hopefully I'm not mispronouncing that a specific tube, specifically the RCA 1C12, FYI, it was actually the RCA 1C21, which is pretty much the exact same as this. All the differences, it had a little black coating on the top. They discovered that when they took that black coating off and they applied a voltage difference between the cathode and an external electrode, they call it, which could be anything from a person's finger to a screwdriver tip or something like that, the tube would in turn become sort of touch sensitive, is what they discovered it would be. And through multiple patents that W.H. Bruns made, we can see all sorts of uses for these things. We could use them for, like, specifically call buttons and all that, but we could use them for momentary buttons, which anyone who has seen an actual Otis elevator has never seen these tubes actually been used for a momentary feature, such as a door open or a door close function. And we'll get to why they did that later, why they didn't do that. I'll just let you know right now, the reason they didn't use these for momentary features is because connecting two different types of AC sources together is very difficult. And in order to do it, it often requires electronics, some of which may not have been invented during this time. So it was just easier just to use normal buttons for features like door open and door close. There really wasn't a justification for creating new technology for something as simple as a door open feature. But W.H. Bruns had multiple patents talking about this thing. Some of them described the actual features of the button, how it worked, and some were more general, talking about control schemes of actual elevators. Some were duplex systems, some were only single elevator cars, but they all basically had the same purpose. They were ways of controlling an elevator, and this is one of the buttons that I have here. This one came from a building in Royal University Hospital in Saskatchewan. This one is not an RCA 1C12, which is what they were using back then. This one is a HVAC 425A2. The reason they don't use the RCA 1C12 is because obviously it had that black paint on it, and it would be really time consuming to buy those and then take the time to scrape the paint off. I mean, the paint was an unnecessary feature. So what they did was they just made their own tube that was basically the same, and they just didn't put the black paint on. So that is your history lesson for today. And now we'll go into a little detail now about how these tubes actually work. But just quickly, I want to mention why we don't use these anymore. One, for the obvious reason that they're vacuum tubes and they're pretty outdated nowadays. I mean, anything with a vacuum tube in it pretty much screams the early 40s, maybe 50s. So pretty much anything that has a vacuum tube nowadays is pretty much considered obsolete. But that's not one of the only reasons. The second was, of course, that from an accessibility perspective, they're really bad. I mean, what if some blind person was trying to figure out which button to press? And, you know, normally as a Braille person, you have to, you know, feel Braille and all that, and you feel which button is next to it. But the thing is, with a touch-sensitive button, like, if I just grab one from up here, the button doesn't actually push in, it's stationary. So you wouldn't actually know if you hit the button or not. There's no audible cue. It's only visual, which if you're blind, then you're really in the crap hole there. So and another thing is that, as a Braille person, you're feeling around and all that, but you notice here, there's absolutely no Braille on it, so you wouldn't know whether this is up or down. And if you're moving your hand around and you accidentally touch a button that you're, not wanting to go to, it's still going to think that you pressed it because you slid your finger over it. So accessibility was a really bad thing for these buttons, which is another reason why they don't use it. And then there's one which I'm not so sure about now, but I have a theory about it. They said that these buttons were a fire hazard, that a fire could come into contact with the tube or something like that, and then it would in turn activate the tube, and the elevator would go down to that floor where the fire is. Now, I'm not so sure about that because I have not seen any studies from any period talking about vacuum tubes, or specifically these tubes, being some sort of fire hazard. And I've tried heating them up and then running them, and I haven't really been able to replicate anything. Now, here's my theory on why they think that they were a fire hazard. And this will come into effect later when I describe how these tubes actually work. I'm just going to say it right now, these tubes are a cold cathode type vacuum tube. There is no heater on it. If you know anything about vacuum tubes, and I really hope you know something about vacuum tubes before watching this. If you don't, then please go and watch something about vacuum tubes. Just kind of get a basic idea and then come back and watch this. But basically, this is a cold cathode vacuum tube. So there is no heater that heats up the cathode and releases electrons from it. So how does it actually work? It uses basically a noble gas mixture. I haven't really researched it that much, but what I believed believed back then was that if the cathode was heated up enough to make it like a normal vacuum tube, that it would in turn not work like it's supposed to and could in turn activate. Now, I'm not sure how hot the tubes would actually have to get in order for that to be a possibility. I'd assume the fire would have to be pretty close to it, and if that's the case, the glass might actually melt away and thus the vacuum tube won't work anymore. But that's just the theory I have on why these tubes could be a heat-sensitive fire hazard. And no, I'm just going to say it right now, I don't believe these are actually heat-sensitive in the sense that they weren't meant to be heat-sensitive, but if heated up very well, they could actually become a hazard. But we are not going to worry about that because there is nothing that's really that hot near us. I mean, there's a fireplace behind me, but we don't have to worry about the fire getting out and breaking our tubes. So we'll just get towards how these tubes actually work now. So how do these tubes actually work? Well, it's actually pretty simple when you think about it, but when you actually go into detail, it doesn't seem quite as simple. But we'll start at the very basics here. So there are 3 electrodes in the actual vacuum tube. You have the cathode, which is the big circular ring at the bottom. You have the anode, which is at the very tip top, just a little simple little pull there. And you also have the grid, or sometimes they call it control, which is just a little ring in the middle. And that's really all you need to know about the electrodes. The 4th electrode is, they call it an external electrode, which could be anything. Usually they describe it as your finger, but it could also be anything that's technically a conductor, so it could be a piece of wire, it could be basically anything conductive. So what actually is used here in order to activate the tube, it basically relies on the principle of there being a grounding rod somewhere. So normally between the cathode and the anode, there is an applied voltage in the DC range of positive 135 volts, with the anode being more positive than the cathode. Now, these tubes, the breakdown voltage is described as being around 180, but that's an estimation, and based on how well they actually made these tubes, which back in the 40s and 50s was not an exact science, it could vary quite a bit. So basically they kept the voltage down enough where it wouldn't be able to activate by itself unless you increase the voltage high enough. Now, how do you actually activate these tubes? Well, you need to lower the breakdown voltage. So you have the applied anode voltage at positive 135 DC. The breakdown voltage is normally around 180, and you need to bring that breakdown voltage to below 135 or at. Now, how they actually do that is they basically excite the gas molecules inside. Basically, there are noble gases in here, mostly neon and argon. That's how it creates this nice orange hue when you actually light it up. And in order to excite the gas molecules, they need to apply an AC source between specifically the cathode and the external electrode. Now, the reason it has to be AC is because obviously there are lots of insulators around us. I mean, when we touch the tube, I mean, we're kind of an insulator. I mean, our resistance is kind of high, so that's obviously a lot of resistance. But between where your foot touches the ground and where the grounding rod is in your house, which there does need to be grounding rod for this to work, there could be lots and lots of resistance. Now, if we use DC as the triggering voltage, it wouldn't actually work. DC can't really jump across a giant gap unless the voltage is super, super high. But we can't have the voltage that high. So what we use instead is AC. And the reason is because AC can travel across capacitors. And when two conductors are separated by an insulator, such as air or something like that, it creates a capacitance which AC can travel through. Now, granted, it's a very poor capacitor, and the AC amperage that goes through it is only it's only a few nanoamps, so like not very much. But one nice thing is that you don't actually need that much for these tubes to run. So 1 nanoamp or something like that, it excites the gas molecules enough in order to lower the breakdown voltage, which in turn causes the tube to activate and turn from a non-conducting into a conducting state. So, with that out of the way, we'll go into more detail in the next video about how these tubes actually are wired and ways that you can wire them. And then after that, we'll also talk about some cool features that you can do with these tubes. See you next time.